Hi everyone, welcome back. In today's video, we are going to talk about the fundamental analysis of a Dockerfile. We are going to go deep and understand all the instructions that you can give in a Dockerfile. Now I know you guys are already aware of the Docker architecture. We have spoken about it multiple times in this channel, but if you have not seen those videos, I highly recommend you to go and check them out. Just so that we are on the same page, there are three main components in which we can break the architecture from a logical perspective, and Docker image is the central part of it, Docker container is the final part of it, and Docker file is the initial part of it. And that Docker file is what we are going to analyze in this video. So let's get started and see all the options that we have available to modify and to create image according to our requirement. So we are going to start our discussion with this Docker architectural diagram, and this is the component which we are going to discuss today. In fact, the component which is responsible for creation of images. So we know that images are created out of Dockerfile, and that Dockerfile itself is nothing but a list of instructions. So those instructions have a specific task. Every instruction is expected to do a specific role within this Dockerfile, and the interviewer is expecting you to know the fundamental differences between those instructions, because there is a lot of overlap in what those instructions can do and cannot do, and what is the best practice and which one to use where. And hopefully by the end of this video we will have a good understanding and a fundamental analysis of all of those instructions. So here in my terminal I have one empty text file. I have called it as a Docker file. So the first instruction that we are going to check is the from command, or from instruction. So basically this is the underlying instruction on top of which everything else is going to be built. So if you are building a house, the primary requirement for you is to have a land first, right? So you can think of this base image as the primary requisite for your Docker file. From this point onwards, you will keep building the instructions, or keep building the commands till you get the desired form in which your application is supposed to work. So in my from command, I have given the base image as busybox. So what I am telling my Docker engine is that Docker, please go and fetch the busybox image, use that as your ground, and now whatever I am going to say in instructions in this file, keep building on top of that ground level. Now in order for this to work, there is one prerequisite that you should have, that is the connectivity to a repository or a registry. So this is the part where the images are pulled or pushed to. You can also have your local registry, and it makes a lot of sense to have your local registry in a CI and CD process, but generally if you do not specify a registry, then Docker Hub is where these registries or these images are pushed and pulled from. Now your machine needs to have internet connectivity, so first the Docker daemon or the engine is going to look for this busybox image locally within my server. If it is not able to find it, then it is going to go and fetch it from the remote registry. So let's see how to do that. So this is my present working directory. All I have to do is execute this command, docker build, and in the current location where I am, and hit enter. Now the interviewer will ask you a question on this instruction from the perspective of registry and from the perspective of multi-stage build. And this is the place where we have a very good documentation for Docker registry, how to configure it, how to have it in your local server, so that you don't have to push and pull to the remote server every time. This becomes very helpful when you are doing CI/CD. Docker provides a very good documentation over Docker registry and how to configure one locally. The use case for you to configure a local repo is in order to provide isolation. So imagine you are in a scenario where your images should not be publicly hosted on the public registry. That's when you should host your own DTRs. So do remember to check out this particular section of registry overview. And the other question that would be asked to you with respect to this instruction is for the multi-stage builds. Now, multi-stage builds are specific to Docker Compose, but interviewer will expect you to know what a multi-stage build is. So we are not covering Docker Compose in this video, but let me just give you a brief overview of what that means. When you're doing a multi-stage build, say for example you have a from command where you take an image, say for example image 1, or yeah, let's call it image 1, and then on top of this image 1 you run another instruction where you are installing or configuring something. Now, as a result of this install and config command, you are getting multiple files that are created, maybe in multiple folders. Let's call them folder 1 and folder 2 and so on. These folders are needed for you at the build time only, but when you want to ship the trimmed down version of this image, you do not want these folders to be part of the same. So what you do is that you define this section, this entire build section, where you have these folders as stage 1, and then in the same Docker Compose you define another service, call it stage 2 or read-only stage, where you take out these folder and then ship the slim version of your image. But in this stage also you will have to give a from instruction, and in this from instruction you will point to this guy, the output of the first stage. So those two are frequently asked questions with respect to this particular instruction. So the next command that we are interested in is called a run command. Now, as the IntelliJ says, that you can execute any command by using this particular instruction. So if you want to install an application, if you want to update the base image that you have taken from this particular image, you can do that by running this instruction. Very important instruction and very simple one to execute as well. So you have the identifier, you call it as run, and let's say you want to do echo and we save this file, go back here, and then what we do is we say build 1.1. The important thing for you to know in this instruction is that as soon as you give run instruction in your Dockerfile, there is a new layer that gets created on top of your existing image, and that is this SHA. That is what is reflected here. Now, with respect to the run command, the question that would be asked to you is when or in which scenario you will be using multiple run calls, multiple run instructions, and in which scenario you will have only one run call or run instruction and call multiple commands sequentially. So try to analyze that part. Just let me give you a hint. With every new run instruction that you give, a new layer is created. So whenever you want a separate layer to be created for a separate instruction, that can be a good use case for having a different run command. But then there are other use cases or other places also where one is preferred over the another one, and that is something that you can find on the help doc of Docker documentation. So make sure that you check on that part. So the next instruction for us is called env, and env stands for environment variable. So you basically define a key and a value. These are the variables that will be present within the image. So you create a variable here and you give it a value, or you create a key here and give it a value. This value will be persisted in your image. So if I go here and I say that my key name is let's say build, and let's give the value as 1.0, 1.1, or let's call it 1.2, and save it. So a new image is getting created for us, and it will be tagged as image 1.2, and that image is expected to have an environment variable within itself, and the value of that variable, or the value of that key, will be 1.2. all right, so let's execute that. So now here in the container, if you do an env, you will get this key which you defined here and the corresponding value for it. So anything which you want to persist inside the image, env is the instruction to use. Next instruction for us is copy, and like the name suggests, you copy the content from your source to the destination. Most likely in this case the source is your server from where you have the files, and the destination is within the image if you want to persist a file. Now there are multiple ways in which copy can be done. There is another instruction which we are going to talk about. It's called an add instruction, and the syntax for this is pretty simple. In the source I don't have any file here, but if I create a test file here, I can create a file here. Let me call it a test file, and within that test file I can create test data. So the source for me, I'm going to use a relative path. I'll call it a test file, and destination I want it within the temp folder. So that's all I have to do, and let me rebuild this. So if we do an ls in the target location here, we will see this test file. Okay, and it has the content. Fine. Now there are actually a lot of questions which are asked for this this particular instruction. One, I told you that you can do copy with other instructions as well, like an add. Add is one way of doing a copy paste. When we talk about add instruction, I'll tell you where that is preferred. But then when you are copy pasting, or when you are copying content from the source to the destination, you are also copying the permissions with this file from the source to the destination. Take a look at this documentation. It explains the two forms in which a copy is executed, and you are expected to know this particular syntax, where you can change the context of the user who is going to have the access right on the file system with the copy and paste. So that is the most common question that is asked with respect to this instruction. So next instruction for us is expose, and expose is basically you are exposing the port in which on which your application is running. So BusyBox does not have anything to expose, so let's do one thing. Let's take Nginx, and then we will expose the port 80 here, and let's save it and build it. This is the image that we created. So let's run it, but we will also use -p. So -p is for exposing my local machine's port and port forwarding it to the container. Again, I have explained the port forwarding, the volume mounting, and all of those commands in other videos. I will be sharing the link to those videos somewhere in the I button, so do check out the kernel commands, or check out the Docker commands, where I have explained that from the perspective of runtime environment building. So if you do a Docker PS, now here, earlier there was no port that was exposed or forwarded. Here you can see that a new port definition is provided. What this means is, if you do a curl at localhost, you should be able to access the content of this particular image. So here, if I do localhost port 80, I get the welcome page. Okay, so the kind of question you will be asked here is, what if you have not exposed the port in the Dockerfile and you still expose it on the runtime? What is the expected behavior? Next instruction for us is add instruction or add command. Now, how this is different from the copy instruction is, in copy, the source and the destination are more or less the file systems. Okay, you are saying that you copy from a file system and you paste it in the remote file system. But here, when you want to download certain things from a URL, that is where you will be using add. The rest of the things remain the same, but the only key difference is that your remote URL can be acted, or your remote URL can act as a source for the destination. Again, the syntax is similar: source, destination, and in the source you can give either the local one, or you can give either the URL one. The question on this instruction would be asked, what is the recommended way of doing copy? The recommended way of doing copy is still by the copy instruction, and the reason for that I have already spoken. You have a way of providing ownership onto the remote file system, and this one add is specifically used for URL based copy paste content. And if you want to copy a content with a specific, say for example, you want a tar file as the output of your add. So those kind of use cases are where you will be using add. In general, don't use the run command to do the copy. Don't use the add unless you are doing it from the URL. Use the copy one with the change owner arguments. The next command for us is the work directory command. So this is the command which you would set in order to set the context of the follow-up commands. So say you want all of your execution to happen in a particular path, maybe OPT software, and then whatever you are doing, you don't want to give the entire context of the path every time. You just can follow on with the relative locations. So this is what you will be using, and syntax is pretty simple. So this would be your work directory, and now if so every command that I write after the work directory, say for example I am doing a copy command after this, and my source and destination is here, what this destination will refer to is actually, this is going to be same as doing this. So instead of giving the entire path every time, you can just set the work directory, and then all the relevant commands that you run, be it copy, be it run, or be it add, they will all be executed in this work directory. Next command for us is volume. Now this volume creates a mount path or a mount point with a specific name, and marks it as a holding external mounted volume from the native host to the other containers. I have again explained this in detail in the Docker communications video which I have created. So if I repeat the same thing here, it won't be good. So just go there and check that video out. Very important instruction, and I have explained it in detail how to use it, and what are the common questions that are asked with respect to volumes. Next instruction for us is called user. So if I run a command, who am I will be a root user, because I have not specified any user by which the container should start. So by default, it takes the user which has been provided in the base image, that is, whatever user was provided in this image. But I can override that with this particular instruction. So let's use a daemon user, and let's save the file. Now, if I do who am I would be called daemon, or the user which I gave in the Docker files. So this instruction, it basically sets the context for the container. Whenever the container starts, this is the user that is going to be the default user by which you will log in. Interview question which is asked here is, how do you override the user? So basically, whenever you go into production, right, you don't want your containers to start with a root privilege, with a root access. You actually, this is part of the best practices. You actually should have a user, an application user, not a daemon, but some nice name to that application user, and only that user should be able to execute or should be able to carry out the tasks within the container. So next command or next instruction for us is called labels. Now, labels is a metadata that you are putting on top of your image. Very useful when you are doing an inspect and you want to understand or you want to have a better management system for your images. You want to tag some images as QA image or QA labeled, QA certified, or some as production ready. So by looking at the metadata of the image itself, you can identify what is the value. Let's say this one is version name, or let's call this release version, and we'll say this is needed for a hotfix. Let's save this and exit from here. Build this guy. Now this is not an environment variable, so remember, you will not find this label inside the container. This is a label for the image. So what you need to do is .docker inspect this image what you created, and then grep -I for label. It says null because it needs a little bit of space, and this much should be enough here. So you get metadata on the image itself. The interview question that you will get here is, how do you provide metadata on top of your images? So labels is the instruction that you give. This information is only for the image, not for the container, and the information is embedded on the image itself. So no matter where you keep this image now, no matter what you tag it with, it will always have this metadata. Now, like labels, there is one more very interesting instruction command that we can provide, which is called arg. Now arg is defined as a variable, and it is the scope of this variable is only within the build phase. So if you want to pass, like I said earlier, that Docker Compose is where you do multi-stage builds. So if you have certain variables that you want to pass on to next stages, or if you want to use certain variables only for the build time, not in the container, they will not be present on the container or in the image. They will only be available when you are actually doing the build. Then at the last, we have two of the most commonly asked instructions. One is the CMD and another one is the entry point, and they are very similar yet very different, and it's very important for us to understand what are their similarities and what are the differences and which one to use where. So let's start with the CMD one first. So it's an executable like the Our definition says it's an executable. You can give the command in either the JSON format, in this case, where you have to put it in the double quotes, or you can directly put it as a shell format. Let's say I give a command and I say who am I. So whenever this this image is going to create a container, this is the executable command that it is going to start with. So let's save this one and see how this works. So before I execute it, just notice here in the metadata that we were seeing earlier, the earlier command which this image was having was sh. Now we are replacing this sh with this command who am I. Let's call it image 9. So now if we do an inspect of image 9 and we go into the the command section, you will see that this got replaced, right? So now when the container starts, it would not start with sh, it will start with this particular executable. Let's run it. So if you see, no new container got created, and the reason for that is it's already created and it's already stopped. So if you see here, this container, which was with the image 1.9, it executed a command and then it just finished its task. So one key thing you should remember is containers are meant to serve a purpose. Once that purpose is done, they are supposed to go. So those containers who are not active, who are in a completed or exited 0 status, if the exit status is not 0, then it is an error, unless there is a business exit code that you have provided. But if the exit code is 0, it means that the container came up, it did its task, and then it went away. So this time the container did not start with sh. When it was starting with sh, it was going to the entry point, which we'll talk in a second. So let's first see the log of this container. So if you see docker logs, let me copy this guy, paste it here. So that's what it did. It just ran that who am I command, which was overridden by the instruction that we gave, and it's saying that you are a user who is called root, my task is done, and I am exiting. Now, one common interview question is asked, can you have multiple CMD sections? The answer is no. Even if you see here in my Visual Studio Code, the first one got dimmed out. It is the last one. You will not get any error, but it's the last one that will be executed. So if I do let's do ls-l, and let's do it for, again, the container, it went into the execution mode, it executed the command, and then it exited with the exit state or status of 0, but it did not execute this particular command. So if you see the logs, it just printed the list of files that are present here at this location. Let's try to see if we give one more argument and we say also give me the list of files that are present in temp, then what happens? As expected, no new container here, but there is a new container here. And let's see the logs of this guy. All right, so there is nothing in the temp folder, so it is showing empty. There is something in the root directory, so it's showing the context of the file. So you can give the arguments here, but this command will not change at all. So that is one interview question which is asked, like how many CMDs you can have in the Dockerfile and which one gets executed, or what happens if you have multiple CMDs. in the Dockerfile. Now let's have a brief overlook of the entry point, and then we will see the differences and the similarities between the two. So entry point is again very similar to the CMD command, but here in entry point what you do is you can again pass, the syntax is similar, there is no change in the syntax. Whatever you used here, you can just change this one and say entry. As expected, no new container, which is in the running state. There should be something in the dead state or completed one, that is this guy. And let's see the logs. It went into temp, found nothing, and didn't return anything. It went into the root location and found something and printed it out. Now they are pretty much similar, right? What we did with the CMD, we did the same thing with the entry point. Now let's go back to the CMD, and what if I do not want the list to be my executable command? Yes, I have the image in which the CMD is provided as my command, and instead of CMD, what I want is I want I want to know who is the user that is logged in. So I just want to know, I just want to execute the who am I command. So how do I do that? When you are running this image, so 14 is the image in which we had the CMD and 15 is the image in which we have the entry point. So when you are running the CMD, instead of just running it without any argument, what you do is you provide an argument here. Right, now let's see the log of, let's first see the container. Container came up and then it went, but the command now is overridden. So the entire block which is here, it was overridden, and then this new command got executed. Let's confirm that in the logs once more. So this is the container, and as you see, the log says that it's a root user that was logged in. Now in case of entry point, if I do the same, let's see what happens. So I already have an image which is tagged as image 15. So let me run it with image 15 and see what happens. Now in this case, I get an error, right? Now let's see the container, why it, if you see here the command itself, you will see that in the previous run, the entire block of my instruction got replaced, the entire argument section got replaced with this command, but here there is no replacement of the command, it has just been appended at the end. Let's see that in the logs. So it says, who am I, no such file or directory. It's trying to list, it's taking this command, this executable, as an argument. It is not taking it as a command which CMD does. So that is the key difference. So in case of the CMD, when we provided the argument at the runtime, at the time of creating the container, what happened is this entire thing, this entire section from here to here got replaced with the who am I command, or any command that you will provide at the runtime. But when you try the same thing in the entry point, what happens is that it appends So it appends that command as an argument here instead of removing or replacing this section. So basically the executable of listing the files is not replaced, and this is when, so this is one key difference. Nothing in the executable got replaced. Whatever you provided at the runtime, that got appended as an argument. So if you have a use case where you absolutely must have one binary or one executable to be executed every time the container starts, like in case of Nginx, there is an sh file that gets executed every time the Nginx has to start. It configures the server. That is provided in the entry point, not in the CMD. So that if you inspect an Nginx image, you will see that there will be an sh file listed here, and the arguments to that sh file are provided with this command. So hope you are able to understand the difference. Both of them have the same syntax, but the CMD can be overridden at the runtime. Entire block can be overridden. Entry point, you cannot override the entire block. Whatever you provide at the runtime just gets added as an argument. You have to specifically add entry point override argument in the runtime to override it if you want to, and that's the reason why the preferred way of executing a command is by using the CMD instruction. Entry point is only used when you must have certain scripts or certain binaries to be executed every time the container has to start. So we can use both of them together in conjunction, and the entry point can only have the command part, that is this one, and this guy here can be totally taken out, and you can only keep the arguments here. Right, so this is the correct way in which you use entry point and CMD. So these are the arguments, this is a location. So whenever you give a new argument at the runtime for this image, that will be appended here in this place, and not at this place here. So the interview question on these instructions are: when to use CMD, when to use entry point, what are the similarities, what are the differences, and also can you use multiple entry points and multiple CMDs? The answer to both of them is no. There should only be one entry point and one CMD. If you have multiple, the one at the last will be taken or given the preference. So those are all the instructions that you should know. Those are all the instructions that are the fundamental instructions for a Dockerfile. I hope you learned something new today, and if you did, do share the channel, do share the video with your network, and I will see you in the next one. Take care.